Hey everyone, how are we doing? We are got some questions. We already got some questions right here. Leah, good to see you. I was wondering if you could help me out on number 3 on 474. Let's go take a look. What do I got open right now? I got a bunch of stuff. This is 474, assignment 2. Let me go download it. Cliff, what's up? How are you doing, Cliff? Mubot, you awake here? Mubot's not awake. We got to wake up Mubot. You can program macros into Mubot. I haven't done that yet. What's up, Trace? Good to see you here, Trace. Oh, I totally got coffee. Oh, I totally got it. Might have even caught a Pokemon or two. Mubarak, good to see you. We're waking up Mubot. We're waking up ourselves with this coffee right here. And thank you, everyone. So much positivity. Everyone knows I love that positivity. It's it's a bit of a marathon you feel sometimes. We talk about that. But we are destroying this. We're doing great. We're gonna grab this assignment right here, hop into it, and start working on this in 1 second. Here we go. Ooh, let me do something before I forget. I'm going to upload the notes from class today. That's probably my one shortcoming. I only have one shortcoming. And that is that sometimes I forget to upload the R notes. So I'm trying to make it a practice between classes to upload the R notes. So we are uploading the course notes or the R notes I take during class right now. So we'll be starting on the assignment here in just probably about 30 seconds. Not even, because I just got it loaded up. There's the 474 notes being added, and there we go. So that's got it. Let's pull back up the chat, see how everyone's doing. Mubot, you should be giving out points. What are you doing, Mubot? Oh, I wonder if I could make a macro for Mubot to get points. What's up from the gym? Let's get pumped with some stats. Got to be doing, what exercise are there today, Timothy? Could you show me real quick how to make a chunk on the R? Yeah, let's talk about that real quick. Let's talk about that as we go in here. And first start working on number 3 for 474. Let's hop into it. We'll mention that too. Number 3, 474. Okay, so this is number 3 for 474. Now, chunks are where we write our code. So we're going to go down here to a chunk. There's the chunk. Now, the deal with chunks are you can create a chunk. So here's how to create a chunk by just going right here and going to plus chunk. Now, this is the name of the chunk. So you don't want to do this. This will cause problems. It'll get mad because there's 2 chunks with the same names. But you can call your chunk whatever you want. Usually you try to call it something that logically makes sense. Shoulders and buys, great stuff right there. Oh, I broke the chunk. Timothy, what are you doing? We're destroying the world here. No. This is Chunk Brian, no. And Chunk Brian exists right there, and you've got your quick options to go through there. So Cliff, little advice on creating chunks, and we're here on chunk 3 on 474. So let's go take a look at this question right here. Write a command that uses which and NA. You can use which NA. It's fine. Which, length, NA, all that great stuff. We've got the price column in the buy box data frame, and we want to see the software might bug out and fail to record if we have all these NAs, couldn't parse all these issues, it didn't take the data, or there might not be a price listed, someone didn't list the price for the notebook we're looking at, or it's no longer available. All these things can happen. And there's just so many different ways that missingness can occur. Thank you, Cliff. 20 points. Mubot, give him 50 instead of 20. Might try to code this as a macro later so I could just hit the macro button. I could code on the stream deck. Oh my gosh. I could have a button to give up points. Got to check this out. Might try to do that later. I got too many ideas. So let's go right here. Write a code that uses which, length, and which that prints out the total numbers of NA in this column. So we've been talking a lot about NAs. They stand for missingness. So literally like you have a train going. And we just go out here and we go train and we go choo, 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 choo. And there's no one driving the train. There's no one in the front seat. There's just 2 people in the back of the train being like, what's going on? And you can see it right. So the very first position on the train has no one in the train. The second seat has no one there. And the third and fourth have elements 8 and 9 respectively. This is a numeric vector. It's just numbers. You could turn it into an integer vector. The class of the vector is displayed up there. The length of the vector is also displayed, and a preview of the element of the vector is being displayed for us. So if we want to figure out the total number of missingness in vectors, there's actually quick ways to do it. And I'm going to kind of give some hints to this. I don't want to solve the whole thing. I'm going to give some hints. I'm going to find out instead, and let's put up here a note once again. Similar but different work. I try not to give away all the answers. I want you to think through and then solve like, okay, wait a minute. So we got this vector. And to pull up a vector from a data frame, you would just go to a data frame you have open, like Survey 10 Classic, and you would just look at the vector. So make sure you have a vector to start. Make sure you do this in little bits and you have your vector. Well, we have this train vector right here. So with this train vector, what if I wanted to find out if something is NA? Who has an idea for a code right here for me to find out is something NA? Like, is something NA in this vector? Is something NA? Hey, Trace, can you delete that real quick? Hints for those who caught that real quick. If you want to, yeah. Wink, wink, wink. Trace, you are totally on track right there. You're getting it. Is .NA. Don't worry. You did nothing wrong. Sometimes I just might ask for that. And Trace, 20 points right there, helping everyone out, following along, knowing what's going on. You know what? I'm bumping this to 50 because everyone's following along in the chat right there. You just have to make sure to use your right vector. What is this returning now? What is this returning now? Every time I see retracted, I think it's redacted. Redacted. So what do we have right here? We have trues and falses for if something is NA. This is a logical check right here. But probably the easiest way to see how many NAs there are is to do this. And there's 2 NAs. Just look at the code as it evolves. From looking at the items on the train to asking if those items on the train are NA, are they missing? We're just saying, were they missing? To asking how many missings are there? To asking what is the % of missing? Now, there's other ways of doing this, ways that are suggested. Please tell me if you ever think the grader is unfair. We could find the positions of the NAs, but that's just where are the NAs located. Let's rearrange this train right now, and here, what will this code return? Important to know what this code will return. What will that code return now where it says which is NA? So it's going to do a logical check on the vector to see if things are NAs, and then it's going to say which to return the positions of the things that are NAs. My goal a lot of times with these videos is that I want to show you the code and I want to get you there. Like if you're following along watching, be like, I'm getting it. And then you're writing the code too. So I don't usually try to end on where the code stops. And then I do extra. So be careful. You're not meant to copy down everything. You're meant to be like, okay, how is that working? How do I manipulate that? How do I use that? You're meant to like take what I'm doing and look at it and be like, okay, what is that going to return right there? Because I can show you everything, but then if you're not, you have to think through it and be like, how does that work? What is price in? Price should be in the buy vector. It should be in the buy box. Let me load up the buy box. It should be in buy, and it should be in price. So price is in the buy vector, and we can see some missingness in there. So Timothy is correct right here. This will return 1 and 4 for this code down here. Great question, Leah. Thank you so much for the question. We have down here is NA, which is a logical check to see if things are NA in this train vector we created. And then we see that this is NA, true, false, false, true, because that's where the NAs are at. And then we ask which turns the trues and falses into the positions of the trues. So now we get 1 and 4. From here, we could just ask, be very careful though. Here's what you don't want to do. Ooh, you don't want to do this. Because now we just took the sum of the positions. Could you count how many? I bet you could. What code are you thinking about, Timothy? Is count a code? No, it's not. I didn't think it was. It'd be nice if it was. You can sum them. You can do which length. A few ways of doing it. If you feel like the grader's unfair, please contact me. Already a few people have contacted me. Some have gotten points back. Some haven't. Anytime you think you get points off where you shouldn't, let me know. And I think that's a really good coverage of investigating NAs right here and finding out how many there are, where they're located at. Like we know the NAs are located in positions 1 and 4. Don't run that lower code. That's the sum of the positions of where NAs are located, which is not, we don't do that here. I mean, it just doesn't really make sense. Oh, no, that's, you know what? We're going to do a Hacker Man thing right here. We're always up for some Hacker Man. Let's do this. Let's do this count NAs. Function. Count NAs. Count A is going to take a vector X. Let's call it vector. Like calling things vector. And we're going to go right here and go to sum. And then we're going to go right here. And we're going to go around return around this. And this needs to be vector. And then let's go here to count NAs. And then we go right here and we run by $price. There we go. We now have a function, count NAs, thanks to, once again, HackerMan. Let's go back here to the main screen. We'll be talking about Stat1 Hackerman again. So we'll be talking more about how to do functions later on. That'll be something we do in 474. Just a little function right there, nice and quick. So we can just do something future if we want. Like we're like, hey, we really like counting those NAs, but we don't like writing all that code. Well, if we just want to give it a vector, then we just write our own user function. We could even put it in a package. I'm sure someone's got a package to count NAs. I'm sure there's a function that exists. On question 4, when I run the inspect code, I only get yes. Ken, let's hop to Ken's question. This is once again BAS 474, question 4. Let's go take a look at this. Let's see what's going on. Maybe there's an error. I haven't heard yet that there's an error, but you never know. So this is question 4 for BAS 474. Let's go down here to the chunks. What? Here we are. Q6. How dare you? Here we are. We're just putting NAs in some stuff right here. So let's go ahead and run this. Do not change the code here. I'll change the code if I want. Okay, we'll run all the code above. I don't think I have anything else. Break it. Here we go. Okay. Let's take a look at what's appearing. I think I know what the issue might be. So this is what we covered today. And let's go take a look. Let's run the code. And whoa, I think we're getting what we should be getting. Okay. I think the issue is, if you're not getting all of this right here, I'm betting yours is appearing below. Is your output appearing below, Kent? Some R's are set up to do inline output that I'm guessing your output is appearing below the chunk. If your output is appearing below the chunk, there's probably a way to scroll through and you should get the 28 rules here. And we could talk about rules again if you want. Mine had multiple pages that had to click through the 25 exactly. You won't get caught. You won't get taken off. I think we have a don't print on this, don't we? Let me double check. No, we don't. You shouldn't get pointed off for excessive output here. Were you able to scroll through, Kent, and look at the additional rules? Yours is probably appearing below. My R is just set up differently. Some people want the more visual output up there. I prefer the more down here. This can be changed in the tools and the R Markdown. If you go here to tools, global options, and R Markdown, and if you make yours look like mine, if you pause the screen here, if you want your output to look like mine, which you can be like Brian. You could go over to, the way your appearance looks and all these other things. You could change to, you could be ambiance. What is ambiance going to look like? Let's turn on some ambiance music. I got to make sure I remember which one I am. I'm on TextMate default. Go to ambiance. Chaos. A lot of people like chaos. This will drive me crazy if I don't have the default. I used it for too long. I went past the window by which I could use a different R layout, but if I switch now, it drives me nuts. Can you explain just the statistical significance again? Yeah, let's talk about this. This is question number 4 we're talking about right here. I'll probably have to put a global question number 4 on here. When it comes to statistical significance, and we'll run the statistical significance of the rules again. It's kind of a basic question here, but I mean, there's really no way to answer this without answering this. Where are you at, question 4C? Come here. So when we talk about statistical significance, the idea of statistical significance, and we see it right here, is, yeah, I can't handle it either. People are like, switch it to dark mode, easier on my eyes. And I'm like, I went too long using this mode. My eyes are used to it. I burned out my eyes. They were burned out when I was born. Bad eyes. 2 eye surgeries. When we have statistical significance right here, which all of these are statistically significant, this code is driving me nuts today in class. Really, code? Really, it's significant at that level? I have my questions about this code, but I do know what statistical significance means. I feel like it's not passing through that alpha. Let me go look at the is significant code right here for a second, because I feel like that argument is not being used. No, it is. No, it is. Okay. And then we'll do this. We'll do more here. Great questions, Leo. Awesome questions right there. It is using the alpha, and it is the proper argument. So what does statistically significant mean? Statistically significant, we're just going to go to a little chat right here about statistical significance. And let's hop over here to our new screen for people who haven't seen it. We're going to try out our new screen again. Let's go do it. New screen. Here we go. So when we go, this is nice and relaxing now. When we do statistical significance, we're asking if something is likely by random chance or unlikely by random chance. And I just want you to think about if we have user block. Exactly, Taylor. I know I like the new screen right here. I'm trying to use it a little more often. Will it draw on the screen? Zoom in just a tiny bit. There we go. There we go. So imagine we have a data set right here. And this is kind of what we saw in class to begin with. So we have a data set right here. The data set has in it, let's just say 2 values. And what you see in this data set is that there's values here for all these. But now all of a sudden, when there's a missing value for this one, there's also a missing value for this one over here, if I remember how to write this. Does this make sense here? And Timothy's exactly on track right with the unlikely by random chance. But does this make sense here that there is a relationship in this data frame right now that when X is Y, X is missing, Y is missing 100% of the time. So when X is missing, and actually, I will throw 50 points if anyone could calculate the lift here. That's not a fun lift. Oh, no, it's not that hard to calculate. Could anyone calculate the lift here? Good question from a review from class today. Could you calculate the lift? So think, what's the original probability of X being missing and what's the new probability? And the math is not as hard as it seems because the numbers are, there's not that many numbers. And I'll talk about the lift here for a second. What you need is the original probability of X missing. So you need the original probability of X missing. What's that? That's the item frequency. So the item frequency of X missing is what? I should have done 5, but 6 works just the same. What is the original probability of X missing? And then we'll talk about the rule here in a second that would come from this. 1/6. So given X is missing, or given Y is missing, because if we're talking in terms of new probability of X missing, given Y is missing, that color looks interesting here. Given Y is missing, what is the probability that X is missing? Given close, the numerator's wrong. Because here's the numerator. Given Y is missing, what is the probability X is missing? That's the numerator. So switch your numerator to that and you'll have the answer, which it's like, oh. And then think about what it means is that the probability is this much more. So given Y is missing, what's the probability X is missing? And then I'll talk about why this is probably not statistically significant. So given Y is missing, what's the probability X is missing? And actually, you know what? We could actually show how this is not statistically significant. So if Y is missing, which is only this row right here, this is only applicable here. That is the only time Y is missing. In other words, ignore all this up here. Given Y is missing, you're right, Taylor. Great job, Taylor. 20 points, Taylor. You're exactly right. That's all it is. It's 1. Because given Y is missing, X is missing 100% of the time. So then what is the lift? Think about what is the change. Trace got it right there. The change from the original probability is it's 6 times more likely to be missing. It was missing 1/6 of the time, but given Y is missing, it is now missing 100% of the time. So it has a factor of 6 increase. Does that make sense? It's 6 times more likely to be missing when Y is missing. When Y is missing, X is 6 times more likely to be missing from its original probability of of 1/6. Good stuff right there. Is that making a little more sense? Like the lift, the confidence, the support, all this good stuff right here. Because now we can talk about why this is probably not statistically significant. It actually goes back to 320. If you think about permutations, if you were to randomly order this data set, what's the probability by random chance that you would get this configuration of X and Y if you just permutate the data set? What's the probability that the missingness of Y would line up with the missingness of X by random chance right here? We're talking a lot of the same values as we go through this. But just by random chance, if you just scramble the data set, what's the probability that this would occur just by random chance? This where they're both missing together, what's the probability of seeing them both miss together in this pattern by random chance? Not that crazy. It's not actually, it's just think if you randomly reorder Y, you could just scramble Y, and what's the probability that Y would have its missingness line up with X in this way, or a way more extreme, which there is not a way more extreme in this instance. If you just scramble Y, so scrambling Y, not the correct pen I wanted to use. If you scramble Y, oh yeah, it's just 1/6, right? When you scramble Y, 1/6 of the time it would occur this way. Does that make sense? 1/6 of the way, if you scramble Y and X also, And it'll just be 1/6 because just think if you scramble X, the missingness will be in a location, and the probability that the Y missingness will line up with it will be 1/6. So the p-value here would be 0.1666666, repeating, because we're saying the probability of observing randomness like this or randomness more extreme, given that there's no relationship between the randomness, that it's just all due to random chance, this type of pattern would only occur 1/6 of the time. So generally with smaller data sets, which is something we saw in class today, even if there's a strong pattern of missingness, which this is 100% missingness right here, like when one variable is missing, the other one is missing 100% of the time, we don't have statistical significance due to lack of statistical power. And yeah, and so what does it mean to be statistically significant? It means that we think there's a real relationship to the missingness, that knowing that X is missing would tell us something about Y being missing. And we see this with some other data sets that if something is missing, it actually would give us information. Let's go back to the main screen. And let's go look at one of those rules right here. If you look right here, just take a look at this rule. When price, high, and merchant are missing, then low is missing almost 33, like factor increase more. The coverage right here, finally know what this means, is the original probability or of all the left-hand side missing. Oh, that's no fun. So let's go get the coverage of low. Low has an item frequency of 3%. So low's frequency, really? Low's frequency is about 3%. But low is going to increase its probability of missingness by this. Can anyone do this mathematics in their head? And it's actually, when you look at it, there's a little bit of something making it easy here. Can anyone times this in their head? I can. I'm going to get it pretty down decimal place accurate. So this is the original probability of low missing. That's the original probability of low missing. I got it from low's coverage. Also, the item frequency would tell us. And then here's the factor increase. So what is this going to multiply when we take the original probability of low missing and then its factor increase right here? What will this solve for? Do it in your head. Or cheat and look at the output. What will this solve for right here when we take the original probability of low missing and then we times it by its lift for its new probability? That will tell us the what, and it's on the screen, and we can solve this. What will that solve out to? Who knows? Oh, well, thanks. So you're timesing this by 0.03. So this is the percent of time they're all missing together. And so this will be the confidence. So the confidence right there is 1, because anytime price, high, and merchant are missing, this means low is missing 100% of the time. The original probability of low missing, which is its item frequency, or the coverage of low. This wasn't in the notes, but it's a little extra thing. If you look at the coverage, it's the item frequency of the left-hand side. So I can find out the item frequency or how often low is missing by doing that right there. And this right here tells us the factor increase, because it's a lift, to the original probability. And the factor increase times the original probability, which you have to remember, this is the original probability, is going to give you the lift. Is this making sense here, Trace? A lot of concepts here. A lot of numbers tossed on the screen to understand, like, what is the coverage, what is the lift, what is the support. The support is the missingness of all of these together. This value right here tells us that 2.8% of rows are missing all of those. So you could actually take the length of the series and divide by the length of the series and find out right here. What is it called? So, yes, it is. Awesome. Lots of practice right here. Lots of practice. That's the data, right? So let's go and row data. And we get this right here. Because there are 3,622 rows where all 4 of these are missing. And so you can see some interesting stuff right here. Like if you were to look at, let's look at this, low and high right here. You see how this rule with low and high has a support of this. But if we go down to low, high here, that's the coverage because this is the left-hand side. Does that make sense why these two are the same? I wish I could highlight them both. Let's kind of show that by taking a screenshot of it. It helps a little bit to understand what coverage is. You don't need to know coverage. It won't be on the test, but it is in the output. And I like to say we should know our output. So what I'm talking about here is this right here, low and high, the probability that they're both missing is the support. But you can see down here with low and high, the coverage is the missingness of the left-hand side. Does that make a little more sense to connect that together here, Trace? I think seeing this might help, that the probability that low and high are both missing is the coverage. I mean, support. Oh my gosh, see, I make a mistake right there. And then, well, it is the coverage down here, but that's just of the left-hand side. So what would the coverage tell us right here? What is the coverage of merchant? Who can explain what coverage of merchant is for 20 points? What does the coverage of merchant mean? What the heck is coverage of merchant? So the coverage of merchant would tell us what? The percent of time what? But yeah, exactly, Harold, right there. Great job, Harold. It would be the percent of time merchant is missing just by itself, the item frequency or the missingness of merchant. Great job, Harold. Excellent work. 20 points right there. Great job. And that's what we should know is like, oh, that's the missingness of merchant, the item frequency for how often it's missing. So great, excellent work right there. I need to set this up as macros. Okay, next question. Let's hop back to space. What is the next question? We had some more questions at the start. We'll put it to open floor right now. Next question, open floor on 2A for question on 475. Oh, everyone wants 2A. Everyone was right with that 2A. They're like, yeah, 2A. Do it. I had the Taylor data. It adds into my values in my goal environment. Looks good. I'm a bit confused on how you're supposed to use the start and frequency to get the right time frame. Could you go over that? Yep, let's take a look for Q4, and then we'll do Q4 back. We'll go back to Q4 here in a second. Wait, do you understand how to read the MD pattern in order to answer the questions? We'll come back here, Leah, on that. We'll come back here. We'll go over to the other one, and then we'll go back and look more at MD patterns. Feel free to ask any questions. I'm going to try to explain the MD patterns and let you kind of think through what all these values mean. I don't want to directly answer every question. Check through the notes, and we'll take a look. Let's hop over here to the new assignment, 475. Let's go take a look at it. You're welcome, Leah. Thank you so much. Everyone's so positive. I love it. Love it. Just keep asking those questions. Be like, what does coverage mean? What does support mean? What does lift mean? What does confidence mean? What does count mean? What does left-hand side mean? What does right-hand side mean? And just get them down and be like, oh, this means this means this. And then look at the data and calculate numbers. It's the way to do it. You're welcome, Taylor. Positivity, 20 points. Mubot, where you been at?
I am Mubot.
There you are, Mubot. Giving out those points. Oh, shoot. This is Future Brian. We're talking about question number 2, Future Brian. Sorry, Future Brian, I let you down. You're probably laughing at this, Future Brian. That's what you do. So we have right here using the Taylor data series from the forecast package. Add in a chunk. Always add in your chunks right here. Let's go here to question 2. And question number 2 right here. Library forecast. Not for cats. Not for each. Forecast. So here we are with library forecast data. If you do not see this, you do not have your library forecast loaded up. So when you load this, this is actually already in time series format. It's always good to look at the objects you create. Promise means it's there. Thank you for promise. Oh, now it's there. You just have to click on it. That's what promise means. I didn't know that for a good year or two while teaching. You just don't know. There's so many things to know. Why does it say promise? It's oh, wait, wrong problem. Wait, wrong problem. So, yep, different frequencies right there. Great job right there, Timothy. I think this one actually already has it. Let me look. This one already, yeah, it's already got it. So it doesn't have a start in here. I guess we could overwrite it. This one is the electrical series. Let's go look at the auto plot. I'm not trying to give away too much, but let's go look at the auto plot and see what the auto plot shows. What information does it have in here right now? We're going to have to change fonts around a little bit here. We'll figure out. Okay, let's decrease font size. Okay, let's take a look at this. So I didn't specify any dates on here because I'd have to go look up this data frame. We can probably get information on this data frame by doing !Taylor. It's a very famous data set. Oh. Ooh. Let's try to do this. Let's try to put this in here. Again, error 1 library forecast. What do you have to do if you have error library forecast? Error library forecast, how are we going to fix that? It says in problem 1. That's problem 1 right there. Problem 1 is that. Problem 2 would be this right here. And so make sure to install .libraries clipped. Install.libraries. Install packages. I can't even think today. Install packages. So what we could do And this kind of goes back to question 1 right here. This is a little dealing with question 1 type here. So I'm going to grab Timothy's code. Start. There it is. Good frequency right here. It's got frequencies already in here. So we're going to try to keep their frequencies. They've got a 2-vector frequency. I'm just going to have to scroll like crazy. They've got the seasonal periods right here, the start on 1-1, and we might break it. So we're going to turn it into a time series. Let's call it Taylor 2, and we can compare what we've done. Okay, so there's the start. Is it capital? I don't think it's capital, right? Nope, it's lowercase. Okay, then we got the concatenate, concatenating a vector. So from Monday, the 5th of June, 2000. So 2000, and it should be, it's mad about the next argument in here. See if it likes this. Is there a code to make your time seasonal, or just like 4 frequencies? I think we should be able to find that. Let's go ahead and take a look at that here in a moment. We'll double check. But there should be. We should be looking at the time series function right here. And Monday, 5th of June, I'm just thinking like what months are what. And I think you find out the hard way sometimes how things work. And then we can go to, we'll just go with daily data right here. It's got the seasonal periods. Let's go look at the time series function real quick. Time series. I don't even know how I did that. Time series object right here. Did a start. They've added their seasonal pattern. We should be able to get it. The delta change in. Let's make sure we have that seasonal element. Here's the start. Here's the frequency. All this good stuff right here. And yes, let's see. Here's our code. People are figuring it out. Awesome. Getting it working right there. Frequency is the number of observations within a pattern right there. How frequent is it? So we might have to use things like 365 for the other one because it's daily data. And you really know you've done it properly if the data turns out correctly. Now, this one isn't, this is 4 times a day. Hence why, let's look at the Taylor series again. It's not a Taylor series, but it's a Taylor series of numbers. Seasonal periods, 48, 336. And let me go look at the half-hour electrical demand. Okay, why is it 48 right here? That answers the question of why this is 48. Why is this 48 right here? Who knows why this is 48? The answer is up there why it's 48. Why is this period right here 48? So this is the cycle of it. So you think this has a cycle of 48. And you can really see it when you graph it. Exactly, because it's half hour for the half hours in the day. So there's 48 half hours in the day because there's 24 hours in a day. And then there's 48 half hours. So this is the one cycle right here. The 336 I'm a little bit wondering about. And the 336. Where's that seasonal pattern coming into play? I will throw 100 points. Here's your hint. I just had an epiphany. I had like a... And that's your hint. I see it now. I see it. And this is already made in the data for us. We could probably, I think under the frequency, we can fix this. This is already made for us, so it's a time series object that's made right here. But here's your hint. 100 points on the line. There's your hint. What's going on here? What's the other seasonal pattern, which is something you should see with this data? So what's the other seasonal pattern we have right here? I mean, we basically have 2 seasonal patterns, which is kind of, I mean, this really just gives away the question. I don't want to go into too much detail almost anymore because it really gives it away when you look at that. Because it tells you the answers to the seasonal pattern right there. Because you've got 2. You got this seasonal pattern, you got this seasonal pattern. And you can see it. You can see seasonal pattern 1 and seasonal pattern 2. Don't worry that it doesn't have the weeks down below there in the days. It's okay. But pretty much. Well, so my hint for this is that. Because I can do 48 times 7 in my head. I could have told you it was 336. Is it making sense right there? I don't want to quite give it away, but yeah, I mean, do you see like let me like show you the data by hand. Woo, 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 woo. So what are you noticing right here about the patterns in this data? Do you notice what's going on right here and what we have? And there's maybe patterns within patterns, like you have a sub pattern. So we have like two real trends in the data right here. And this is what we should have an eye for. We're like, oh, we got this and we got this, which looks to be more like we got a one pattern. I think we can, let me try ggplotlying this. It's a really good talk on number 2 right here. Remember, don't do everything I do. ggplotly. I'm using ggplotly because I bet I can zoom in. You gonna ggplotly? Yes. What we're talking about is this right here. And this is why I love ggplotly. And do you see the two patterns? The answer to the two patterns is 1, 2, 3, 4, 5, 6, 7. And I bet you go over here and you go 1, 2, 3, 4, 5, 6, 7. What's even crazier is we could add an additional trend to this data set if we were just absolutely crazy. And you could have a data set which we could use some differencing for to go back to today's lecture and stuff. You could have this pattern, but you could also have something like this right here. And now I've added a what trend to the data. So now we just got like so many crazy things. Is if this pattern, shouldn't it be 52? Not quite 52, because it's not a, the pattern right here is that it repeats. So now we've added a linear trend. It doesn't repeat every 52 observations. The cycle by which it repeats, the cycle by which the pattern repeats, is after every 300 and I can't remember the number now. I can't do 48 times 7 in my head. 336. The cycle repeats on every 336th observation. Does that make sense here? That's at observation 336, and that's one of the parts of it. Is this making sense? Right? We don't have a linear trend in our data. We don't. I just put it on here for the heck of it. This would just have another trend in the data. It would have these two seasonal patterns along with a linear trend. And this is after sets plus 336 observations. But then the smaller one in here, the little baby one right here, is every 48. Those little tiny ones, which are so hard to draw. Those little baby ones are every plus 48. And those patterns are on every 48th. We see that seasonal pattern occur. So does that make sense right here? This data set has the cycle. So the idea of this being a cycle or a seasonal pattern is that the season restarts. Think about like, the seasons of the year have 4 seasons. So it's not necessarily related to weeks in the year. But if you had like a weekly pattern, it just depends on how your data is collected. If this was collected every hour, then what would these numbers become? This is a good question, especially good time series. Someone collected data every half an hour. What would these numbers become for the patterns for the seasonality of our data if we were to change this to not from hourly data, half hour data to hourly data? So season doesn't have to do with the actual seasons, just pattern. Exactly. It's not like actual seasons in data. Yeah, because then you're like, well, shouldn't it be weeks? So we're looking at the pattern. Shouldn't the frequency be 410 since there's 410 observations, exercise 7? Well, it depends on the seasonality. And so shouldn't the frequency be 410? No, it's just when does the cycle restart? So you could probably do it a few different ways, but see what you see in the data. See what you see in the data. You could really go some advanced ways with it. But not 410 though, because the cycle doesn't restart on every 410. Does that make sense, Hayden? So there's way more observations in this Taylor series. But think about this question right here for a moment. What would these numbers become if the data was collected every hour? If instead of collecting every half hour, what would be the seasonal patterns of this data? If instead of collecting every half hour, we collect every hour instead. The top one should be easy. And then the top one gives way into understand what the bottom one will be. Yep. And so don't do 410. Don't do 410 frequency. 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 410 fre And half of 336, yeah. Because it's just going to be half as much data. And then 336 would represent how many hours there are in a week. 336, I mean, the division of 2 by it. 336 right now represents how many half hours are in the week. That after 336 half hours, we restart the cycle. And this really is the answer to later questions in this. Is this making sense right here, Timothy? That 336 represents how many observations we must go through before the weekly seasonal pattern, hints for the questions, the weekly seasonal pattern goes through. 48 represents the amount of frequencies of observations we must go through for kind of the inner seasonal pattern, which is the daily pattern to go through. We got a cyclical pattern during day, and that is 48 observations. But then we also have another seasonal pattern right here, which is going to be 336, which is the larger one. So I've got them color-coded by those colors to help us see the inner pattern of 48, and then you've got the kind of like another loop. It's almost like a nested for loop right here. Like it's going through, and then it's doing a cycle of week, and then it goes into the next week. I really like this data right here because we understand how days works and weeks works, and you can see here the frequency of observations and when the patterns kind of restart. Is this making more sense, especially seeing right here the patterns we've been talking about with seasonal patterns and the frequency of observations within the season? So you could change. There's multiple ways to do it. I'm interested to see how people do it. And once again, if the graders ever unfair, just let me know. What is the next question? Does this answer number 2? The data is already organized for you to use. You don't have to put a start end time. It's not the end of the world. You don't have to put a start end for number 2. So big hints right there. You don't have to change what number 2 is. It's already created as the time object. But for number 1, you need to put the start end. That's a lot of help. Yes. This is basically number 2. Let's hop back to space. I think we can do some more A rules. Let's take questions on A rules right here and see. I'm actually good on 4Q. Awesome. Yesterday you helped on number 2C, but I am stuck on how to do only a few months, not all months. Could you set me in the right direction? Let me look at 2C real briefly right here and see if I can, and we could go look at it. Leah, excellent work. Great job. I'm throwing 20 points for just being proud of everybody. The biggest thing is you just have to sit down and just like, if it doesn't work, you just say, hey, Brian, it's not working. And then we start fixing it. It's just very easy to get stuck on these things. And I'll make errors. You see me make errors in coding all the time. All the time. Make more errors than real code. Might be true. Let's go down here to 2C, take a look. I'll see if I'm going to offer advice or just kind of work it. 2C, include 3 bar plots. Oh, you want? Okay, so you said, I'm stuck on how to do only a few months and not all the months. What does it want? Oh, no. Oh, it's all the months. So you could, it's all the months. So Leah, don't worry right there. Definitely true in my case. Great job, Nick. Good to see you, Nick. So Leah, it's all the months. Someone's going to only display January, February, March. Oh, it should put etc. there. We should put etc. Yeah, it's all the months. Don't worry. You're not displaying just January, February, March. Which that, I don't want to do it. I'm afraid someone will follow my lead. You would take your table and you would just take elements 1 through 3 of the named vector table. So when you make your, don't do this. You make your table, you put what you want, your categorical variable, which will be W day, comma, label equal true, close it off, put some square brackets for position, take positions 1 through 3. We're doing months anyways. Months, comma, label equals true. Square brackets, 1:3, and then comma, end square bracket, and then put that into a bar plot, and that'll only give you bar plots of the first 3 of the table. Will we have some kind of review practice test or something for midterm next week? Definitely. We'll do a Kahoot. Kahoot! So I'll get a Kahoot ready. Got to get the Kahoot ready this weekend. Crazy weekend. Crazy weekend. Woo! I've almost got another set of notes ready. You saw some of the graphics today. Really excited about one of those sets of graphics. Let me show one of those graphics real quick here. Please ask another question if you got it. Really great questions today. Where's that new time series code I was writing? Is this it? Yeah. Let's go take a look. This is kind of some new graphics we'll be seeing here. Let's go take a look at those new graphics. So with this right here, really amazing graphics. I'm constantly trying to update the graphics and what we're doing. Where'd I put that graphic? It is a better way. Did I make it and not save it? Brian, past Brian, where is your... So Where is it? GG pairs. There it is. Yep. So here it is, and then I loaded it around here. Okay. So this is, could you talk about ARIMA next? Yeah, let's talk about ARIMA next here. And we're not going too big into detail, and then we'll do 1C. You got it. So it's just a real quick aside. If you remember in 320, we used the pairs function. So if you look at data right here, and if you go to the pairs function, it's a neat little function. Really? Not going to... Oh, EX7 bike. I'm using X7. The pairs function gives you the following output, which is a bit crazy right here. I think we need to actually use EX4 bike because EX4 bike only has categorical data. It's a little bit mad about these right here, but let's go look at EX4 bike for a half second here. My computer is acting all sorts of crazy. Let's go take EX bike right here and EX4 bike. And let's do this. And let's take a look. And we'll run the pairs command on it. This looks kind of nice, but what I really love is I love Plotly. And I was astounded when I was going through and looking at what we can create. And we get this sort of object here. Brawl almost struck again, brawl striking everywhere. This is a much better view, in my opinion, of what's going on with the univariate distributions of average temp right here. This is where average temperature aligns. You can see demand has a little bit of a second peak in here. You can see the relationship between the variables. You can actually get the correlation coefficients with the statistical significance of the correlation. You can see where there's negative correlation. And these are just plotted in the order by which they are shown. Like this is the strongest right here, with a correlation of 0.987 between effective average temperature and average temperature. And something we should look at in our data sets, especially with time series data, is the correlation between the X variables. So be expecting, especially in later assignments, we will be looking at maybe other variables would help us explain, and you could even zoom in here and take a look at these points. Oh, R's getting mad at me. R zoomed in. I think it's just holding a lot in its memory. Even a strong computer like this is saying, really, you want to zoom in on that? And I say, yes. Okay, let's go back here and take a look as Brian crashes R. R, don't crash. You got this. So the question was, can you talk about ARIMA next for 3C? Let's go take a look at some ARIMA right here and talk about fitting a model right here. So let's hop back into the assignment, getting it pulled up, and talking about question 3 and fitting an ARIMA model. Where is the assignment? Here we go. Whoops, wrong assignment. Have to find the assignment. Okay. Question 3, fitting an ARIMA. Let's go check this out. Where's our slide? I gotta bring back Brawl. Is he here on these screens? Question 3, fitting ARIMA. Gotta murder myself to say that. Okay, please put in a number here. Don't use the number I'm using. Put in a 4-digit number. Replace it with a 4-digit number. You need to make sure to do that. You will get your random walk. Now the random walk, and mine will be different than yours. The random walk is going to be just completely random where it ends up. That's what a random walk is. We're talking about that today in class, and let's auto plot it. It's mad, is it? Ooh, what you mad about? Oh, I know why. Because, who knows why? 20 points. Why is auto plot saying, and is it saying it down there? It's kind of saying it. Very important thing, why is the random walk mad, and why can I not plot it with auto plot? I could plot it other ways. Don't do this. Don't do that. I mean, you could. Don't do that. Why is autoplot mad? Why did autoplot not roll out? Why is it getting mad right there? Why is it like, nope, not happening? No ideas? What must autoplot take? What does autoplot need? Autoplot takes a certain class of object to work, and it said, nope, objects of type numeric not supported. It said, you gave me a numeric type. It said, nope. Close, not a data frame. Autoplot wants a time series object. Now it said, thank you. It said, I will do this for you. I wish it had an if, like if class numeric turned to time series. It makes sense, but it makes sure we put in time series. So we have to give it a time series object. If not, it just says, nope, you gave me numeric, I say no. And so when we talk about fitting, and I'm not going to do your exact question, don't use the disk I'm using down here. Brian's difference between ts.plot and autoplot. I think there are small differences. A lot of people use tsplot, at least two things I'm looking for. Tsplot is base stat. And I wonder if TS plot will take. I don't use TS plot a lot. Object walk not found. Huh. Well, it did it. TS plot, but I do like the auto plot better. Good question. I like the auto plot look a little bit better. Auto plot also works off ggplot, so I think it's easier to work with your GG elements. So I like auto plot because of this, and I also like auto plot because of this right here. You can turn it into a plotly graphic. So if you look at the amount of work I had to do to get my main title and to get all of these things right here versus the TS plot, which I'm sure has all those options too, is just look at this right here versus look at this. I just think it's a lot sharper. I just like the way it looks. And there's a lot of like layouts and stuff because this is using kind of the GG universe, and that's why it's ggplot compatible. So I do like this a lot better, but it's all preference. A lot of people use ts.plot. So very, very common function, and it's base R. So everyone should have TS plot. So there could be an argument made to use ts.plot, but we've seen there's a lot of really cool functions that we should have and download. And then we can just tell someone download this package. It's super cool. And so now we're fitting an ARIMA model, but we're not going to fit it to this. Let's fit an ARIMA model to what we were just working with. We're going to use a different thing right here. So this is going to fit. We've got a question come up here for 2A for yeah, let's go take a look at that. Is there a reason using just head on the first one is not sufficient for temporal? Because there could be... You got it, Trace. So let's go look at this Taylor series, and let's fit the ARIMA model. Now, hints for the ARIMA model, when we have 0, 0, 0, this means for the autoregressive, which is the first coefficient right here, first parameter coefficient, first parameter. Good idea, Trace. And the integrated moving average, we'll get into more specifics on ARIMA models, but all this is fitting is the white noise model. This is fitting the white noise model. Now, I want you to think about the Taylor series right here. I want you to look at it, and I want you to look at these values. They're big values. Remember how we were looking at the Taylor series a moment ago, and the Taylor series looked something like this right here. I'm going to guess that the fit for the Taylor series, I'm going to guess it's about 28,000 for the mean of the process. And let's go look at the fit. Why did Brian guess about 28,000? Why did Brian, I should have just guessed 30. It's just been like 30. Because the white noise model is going to fit what right here? The white noise model is going to fit what right here? What is the white noise model going to fit? Awesome. What is the white noise model fitting? How do I always mess up autoplot? It's ridiculous. What is the white noise model fitting? It's constant mean. It's constant mean. So what is the main parameter in the white noise model that we're looking at right here? The white noise model, this is a horrible model to fit, but we're just in the basics right now. We're in the basics. We're in the little like just beginnings of this right here. We're not far into this. Someone's looking at this and saying, what the heck? Well, we're just fitting the mean to the data right here. And we've got the white noise model fit to it. This is not a stationary time series. So we don't have a process that has a constant mean, no lack of correlation between the points over time. We have shifts in the variation. This is not a good idea to fit the white noise model, but we can always fit the white noise model if we want. Probably shouldn't. AIC, which we'll be looking at model metrics, is absolutely horrible. We could just go in here and maybe just throw a little that on. And now let's go take a look at that fit. Ooh, look at that AIC going down. Ooh, kind of something going on right there. A little bit better. I shouldn't do it. There's codes I know that are too helpful. We have to learn the theory behind what we're doing. Don't look at that. I changed the auto-regressive to 1. I just wanted to throw that on or see what happened. But also the AIC dropped, which is Akaike's information criteria. We'll be talking about that. We talk about it very briefly in 320 and more in 474. So Akaike's information criteria is model's closeness to the truth. Exactly. So, and then we'll do Leah's question right here. So does that make sense, Trace, that I can immediately evaluate these two models with this comparison metric right here with how close it is to the truth? And we can see right here the standard errors of these estimates. And we could go right here. That's the uncertainty in the estimate is the standard error. And then we have right here the AIC, which is the closeness of the model to the truth. The lower the AIC, the better. And it kind of makes sense that this model will have a continual like drop right here that might be the last day of the weekend, and then it might go back to mean reversion right there of sorts. So yeah, once you know this is closeness to the truth, you just know you can evaluate two models based on AIC. That's really, I mean, yes, Akaike's information criteria is more complex than this. It has to do with the sum of squared errors. Sum of squared errors, the log of that can be negative infinity is the minimum value when our model perfectly fits the data. But the AIC right here dropping this drastically instantaneously tells me that we're doing way better. So good stuff right there. Lots to see. And we fit the white noise model. Don't fit any other models yet. We haven't talked about them yet. And we're forecasting ridiculously into the future using the auto plot, which is so nice. TS plot, if you want to use TS plot with the forecast, we got some more questions. Great stuff right there. Oh, we did that, Zaid. Check out earlier on in the video. We went through a whole big thing, and let me know if you have questions. We went through the MD patterns pretty fully, kind of one of the first 10 minutes or so. So check out that section right there and tell me if you have some more questions. But check out the start of the video right there, and we're going to hop into Leah's question on 1D. But let me know if you have questions. We started the video with some MD patterns. Let's hop back here to space. Does this make sense, everyone? How to fit the white noise model, what the white noise model is, and why probably it's not a good idea right here because this is not a stable process. You're welcome. How are people doing on this question before we head back to space? Like understanding that we fit the white noise model back here. Probably not a good idea. Let's go look at that real fit of it. Probably like, yeah, I don't know about that. We're fitting it to a totally different series. Remember, I'm not always doing your questions. I'm fitting it to the Taylor series, which is what we just looked at earlier on for another question. You're not going to fit it to this series. You might do different things by looking at some differences down below, like graphing the differences. But this is how to fit the white noise model to your data, which you should have code like this. How are we looking? I think, are we good? Fitting the white noise model, understanding what this value right here represents. And then we also see right here, last value to understand, is this is the only parameter of the white noise model, which is the variance or the standard deviation. Variance is in squared units. I don't like to use variance. I just don't like squared units. This standard deviation right here, which I'm always a little bit mad about, it should be this value, theoretically. And I think it's decimal differences, how the way R is carrying numbers in the background, maybe while doing some computations. I don't like that those are different. It's probably just annotating decimals as it's running the standard deviation formula, which is really not cool, R. If you're telling me that's the standard, oh, it's probably that this isn't carried out to enough decimal place accuracy. Yeah, it's probably rounded or something. So how are we doing on this? I think we're good. There hasn't been any more questions. Let's hop back here to Leah's question. Let's do this. The question is 1D for 474. Let's go take a look at that. 1D 474. Where's that question? So you're welcome, Abigail. Great job right there. Thank you, everyone, with all the questions. Here we are. We're going to go to 1D 474. Let's go. We'll hop to the main screen. Question 1D for 474. Question 1D. Quickest way to get to it. Okay. The table command produces a vector of integers, a named vector, that give the frequency of all of its unique values. Yeah, will and still produce a named vector, I think, for numeric data. Much like each column in a data frame is a given name, each element in the vector output is a table is a name. Yeah, that's exactly what I was saying. Frequency represents these names can be extracted as a character vector with the names command, thus developing command that uses which table names and then prints to the screen the names of the two products that appear 558 times in the data. Okay, cool. So let's say we change this. We're going to change this, obviously. So let's go look at survey 10. Shocker, right? When we look at survey 10 right here, if we go here to survey 10 and we're dealing with a categorical variable like handedness, you can see right here, handedness is categorical. It's factors inside of R. And I go to the names vector. What am I doing? Make a table. I'll make a table right here. And what do we have? Let's say we wanted to find the values of which 23 occurs. Do we have major in one of these? I'll do this one. I'll do a second one on this because I think I can do a more complex one. This one's very easy to see what's going on. And that's a named vector right there. So what you can actually do is you can actually run logical checks on this. And watch this. Now we've run a logical check to see if in that named vector, because it's just a name, but then how could I, and it should do this. I've got a few different ways of doing it. How could I find the position of that true? Let's do it this way, because I know this way will work. How could I find the position of where that true is at? It's about to get pretty crazy. I'll make it easier, though, by doing it in steps. How could I find the position of that true? Whichever one, when you hear position of the true, you should think, oh, this code. Which, boom, let's throw a which. Great trace right there, 20 points. Amazing work. Keep it up. It's exactly what we should be doing. 100% following along. So we're going to throw a which around this. I'm going to be over there in that chat. We're just going to throw a which around this. And the which will return 1. Because that is the position. You could unname this. You could do all those things. But let's just store the position right here. And then watch this. Let's go to the names or the levels. Because it is doing them in order, right? Let's see what it wants to return. Check out the name vector output. Print to the screen the name of the two products that appear exactly this amount of time. So what I would do is I would go to the names of the table we just did. And we're making a names of tables survey $10 handedness. There's the names. And guess what? What am I just going to add to this? You might, you know what? That might, oh my gosh. Is it really that easy? But remember, this is, ooh. Would that work? Trace, 50 points. Can you finish my code? Trace beat me right there. Trace. Playing some video games right here. Trace solving Brian's problem before Brian can solve it. I was going to solve it this way up here, which is a much longer way of solving it. But how does my code end? Here's what my code gives me now. But then I know the position of what I want. So since I know the position of what I want, that. Trace is correct. We did just... I think what you have, Trace, works 100%. Because we just took the positions... I want to see if it works on a greater scale. I'm a little... I 100% sure works. 99% sure works. I think it works, Trace. I think it works. Let me pull up one of the surveys that has like a major on it or something. So let me pull up one of the ones that has a major or something more complex than... is major on this one? We should have one with... Oh, there's major. 2 factors, business, not business. Why didn't we collect something more complex than that? This one right here, is there major? Did we really only ask major? Where's a factor with way more levels? I want a factor with a lot of levels. 4 levels, boring. Let me see if we have a factor with a lot of levels. I need like survey 18. I've got bigger surveys. And it works on the homework. Yeah, there you go. That hey, quick way of doing it. Great job, Trace, right there. Definitely earning those points. We got day right here for this. Let's use EX7 bike. Nah, I don't use by data set. What's in data? Merchant. Good. Is this one we're using? Let's go to the shelter data set, actually. Let's go to the shelter data set. That's all. Ooh, that's not good. Data's not formatted. I just checked it too. It works. There you go. There you go. Let's up this to 100% right here. Oh, here we go. Nice job. Excellent work. Let's go check it out. So it works. Code works. Great stuff. Code yours to work for yours. Make sure you're using the right vectors. Make sure you're checking the right values. find the positions of the things you're interested in, and then take the names of that position vector, and you should be good. Could you go over the last 2 bullet points of the end of 474? Let's go check that out, Aaron. Make sure if I forget a question, make sure to ask it. Let's go check it out. So this is the last 2 bullet points of 474. What are those? What are the last 2 bullet points? So, oh, the output, yeah, the statistically significant. Check out the very start of it. Let me look what the last one is. Yeah. So check out the start of the stream, Aaron. You'll see me graphing. Go back in the stream, and when you see me working on the blackboard, oh, Banjo-Kazooie is great. I haven't played much of it, but yeah, you're talking like some Mario, some Zelda right there. That's a great game, Banjo-Kazooie or Banjo, to whatever the next one's called in the series. But check out the very start, Aaron, and we'll see if there's any more additional questions. So I could go back over it, but you'll see me on a black screen talking about statistical significance and how it relates and kind of what it means. Does that make sense, Aaron, right there? Check it out. Tell me if you have questions. But I go over and I do it in like the Khan Academy style. So if you're going back in the video, you should see that right there. You should see me talking about statistical significance and the likelihood by random chance and those good things. What? Any last questions right here? Any last questions? We'll see. Try to do like 1 or 2 more new ones here. I think there was another one. Awesome. Thank you, Aaron. Thank you so much. I try to do as many new questions as we can do, so that way we can fill up the video with stuff and then go do work. I need to go label these videos afterwards. So extend the screen right there. Was there another? I think there was one more. We did the MD patterns. Could you did we do 1C? Last questions. I need to go eat some lunch here in a moment. Let's try to do one more question at least. What is one more question? One that people are going to be stuck on. What is the last question of the day? 1A for 474. Just want to double check I did it right. You bet. Let's go check out that 1A. And thank you for everyone understanding. I try to do as many new questions as we can do so we can get through as many as possible, and then I can eat lunch. How many different products are represented in this data frame? Let's go check it out. Question 1A, 474. Let's go do it. Before any data cleaning validation is done, how many different products are represented in this data? In other words, how many different levels does the name categorical variable have? So when you look at this, there's a really easy way to do it. Like, wait, where's that? Does anyone have a? I mean, you can put it in the chat. No, we can do this in code. We can do this in code. I might just answer this one. I might just show the answer right here. But does anyone have any idea for the answers? Just visually inspecting this, kind of using some of our visual cues right here to like, no, like, don't worry. You're like, oh, you can see it right there. But we'll code it here in a second. I'm probably just going to code this one flat out. Who thinks they know the answer? In the environment, it says 440. Yep. Since it's a factor. 20 points. Like, is it really that easy? We'll do Hayden's question next right here. Is it really that easy? Yep. It's that easy. So there's a lot of ways to do this. We can go here to length. We're just going to solve this one. We don't want to do that. This is going to tell us the length of the vector, which is going to be 126,000. You're like, whoa, there's a lot of levels. But we want to go here to a table and find the length of the table. You could also ask how many the levels of this. Now be careful for your output. Obviously don't do all these ways, but we can get the levels here, and then you can see the answer down here. Do not print that. And you could go, no, you don't want, no, it'll still, well then, yeah, it's just ridiculous. You want to go here to the length of this vector, and you'll get 440 again. So, yep. Oh, and then people are doing the great answers right there. You can keep those answers in the chat. Don't worry. People are doing it a little bit differently. If you notice the format right there, people are using, they're finding the name column with this right here. There's the name column. And probably the quickest way to do this is, do we have an n levels? I don't think that's a function. It is? What? The things that, oh, Kayla's saying it in this very moment. Kayla right there. I promise I didn't cheat, Kayla. I didn't look. But n levels right there is the number of levels. Just things appear in my head, and I'm like, wait, isn't there a function n levels? Like, I think it was Timothy was talking earlier about a count function. There's not a count function unless we make the count function. So we made that earlier today. We just tossed in at the end of this a count function somewhere. We tossed it on. Yep. Oh, yeah. So n rows, n calls. and dimensions and levels. So really good stuff right there, just meaning number of levels, number of rows, number of columns. What's really confusing, and I use encall and row lower space, but there's encall capital and encall lower. I only use the lowercase encall. It drives me nuts. One day I sat down and learned the difference between them, but then I just didn't switch between the capital and upper lowercase. I just use the lowercase and know how those work properly. So that drives me absolutely nuts that there's a function with the same name but uppercase that does nearly identical stuff, but has slight small differences depending on if you're giving it data frames or vectors. Like we could examine right now. Just a real quick examination. There are 20 columns right there. Yep, that's what I thought. Encall on this. There's 20. I think it doesn't. One of these works on vectors and one of these doesn't. Like Y, R, Y. Okay. And then this. Okay, those all work, but now if we switch and we go to vectors, this is where the changes occur, if I remember. So this doesn't work, but this does work. I don't even know why you would need to know that. This doesn't work, and this does work. So the capitalized ones work on vectors where the lowercase ones don't, but I just don't use them that way. So they really, like n row capitalized on a vector will work, but I just gonna run length of a vector. That's what I'm gonna do. I'm not gonna use it that way. So I'm probably gonna forget this again because I just won't use it. You don't use it, you lose it. Let's hop back here and do another question. Exactly, Leah. It's weird, and there's just functions I don't use every day, so I'll forget how they work, and then I got to remind myself and then do a little just practice code and be like, what's the small difference between these and what's it returning? I got it. Nice job right there, Hayden. Excellent work. Oh, wait, was it Hayden's question? Oh, let's try to do one more here. One more. My brain's yelling at me, eat some lunch. Go eat some lunch. Go catch some Pokemon. How's everyone doing? I will take a repeat question right now, especially if people have it. If you're like, hey, can you go explain those MD patterns again? Can you go explain that significance again? I feel bad when I say to people like, go check out the start of the video. But that way we can do as many questions as we can. But if someone wants a repeat question, we'll put the 1 minute timer on right now. Or if you have a question we haven't done. So it's any question right now. But I like to do, and if you have a 201 question, jump in 201 right now. If you got that question, hop in here. So let me know any of your questions. This is always the best screen to ask questions. There's never a wrong time to ask questions, but if I'm on this screen right here and I'm not doing anything, but got the 1 minute timer on, our new space background. What do people think of the new space background compared to the old one? This one actually seems to loop better. It's a smaller file. Trying to interpret the practical significance. Like, are you talking about for the last one? When you talk about like why if something is important to your boss, like knowing something is missing might help us to know that we should collect data. It's like an association. Like if I know that when we don't collect data on variable 1, then that's probably going to tell me that for some reason we're also not going to have variable 2. Like for some reason these in tandem. So as soon as we know variable 1 is missing, we might be more likely to set something up in place. Just say like, oh, usually when they don't collect data on the location of the house, they don't collect data on, let's say, the neighborhood the house is in, which is obvious. That would be like a paired missing. Like you would see whenever location is not collected, the neighborhood is not collected. Like we're collecting data on sales of house, like missing address, missing neighborhood. But you could be missing the neighborhood, but not missing the address. But whenever the address is missing, we're missing neighborhood. So we might say, okay, we know this pattern exists, but maybe we could look into the missingness pattern where we're missing the neighborhood but not missing the address, and we could try to fix those. So it could help us deal with the missingness. Because if we know the address, but the ones where we're missing both, we're not going to try to fix those. So I might make a subset. Like it's just like, does that make sense to everybody? If I have the address, I can find the neighborhood. If I'm missing both, that data is just gone. That data is, I'm not going to be able to fix that. Does this work? All 28 rules are statistically similar to the pattern of missingness occurring more often together than what we would expect by random chance. Yeah, that's great right there, Trace. Excellent work. Yep, you can leave that on there. We'll just leave that on there as a little present for people. Trace is going to retract like ah! But yeah, it's that what we're seeing with the missingness is something that is unlikely by random chance. That when I'm talking to my boss, I'd say like, there's a true association between when this is missing. Like, just think about this. When we don't have the address, we also don't have information on the neighborhood. So you're for the people, Trace is for the people. When we don't have the address, we also don't have information on the neighborhood. So it just makes sense. And it's not by random chance that we're missing the neighborhood when we don't have the address. Like, this is almost a causal, it pretty much is a causal relationship. Like, not having the address causes us to miss the neighborhood because we just can't take that information down. It does not mean things are causal, but in this instance, I would say it looks like we have evidence of a causal, like, because one is an aggregate of another. And you sometimes see that, especially with missingness, that missing this causes this other one to be missing. And you would see that in the pattern of missingness. Like, every time address is missing, neighborhood is also missing. Well, we could have instances where address is present and neighborhood is missing. And then those are the ones we would probably try to clean and we probably try to fix, because we go back and we could, like I said, subset the data, look at where address is present and neighborhood is missing, and then have someone look up those and fix the data set. And then we would fix the missingness. That's how we'd replace missingness. And that's not for quantitative values, because quantitative, we would have to substitute in values, not addresses. Awesome. Great job. Thank you, Leah and everybody. With that, I think we're done for today. Excellent work. Once again, if you ever have questions, just let me know. We try to do as much as we can, practice, learn, and I do mean this. Okay, I'm gonna send it. Yeah, let me send it and say, hey, Brian, look at this, check this. I can't check all quantitative answers, so I want to put that there too. I can't be like, yeah, you got that quantitative one correct. We can kind of do that a little bit during office hours because everyone gets that help then. But maybe for some interpretations, I can kind of look over this and give you a little bit of advice, because interpretations are more open-ended, and then quantitative ones are the ones like, you gotta take a shot here. Do you think you did it correctly? I can make it a little bit of advice, but I try to like let people have a chance to get things wrong. Oh, it's scary, isn't it? Don't worry, you'll be fine. Are we doing nested for loops? We will do some nested loops. Not today, but coming up here soon. On BAS 474, BAS 475. I will see everyone soon. Puppet Shark, you don't appear nearly enough these days. Puppet Shark agrees. I will see everyone soon. Bye for now. Time for lunch. Ah! Why do I always scream at the end? I don't know.